Hello children, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to today's class. Today we are going to discuss about square, square root and cube, cube roots. We are going to discuss about the concept of square and square roots. Okay, cube and cube roots. So let us discuss about the square and square roots first. So square number is nothing but when a number is multiplied by itself. When a number is multiplied by itself, will gives the square number. Okay, na? A number is multiplied by itself gives the square number. Okay. Yeah. Gives its square number. So let us see some examples are based on this. For example, I am taking 5. 5 is multiplied by itself. That means 5 into 5. So 5 into 5 is 25. So therefore we can say that 25 is square of number 5. 25 is square of number 5. Okay, na? Same like that, 12 into 12. 12 is multiplied by itself. 12 12s 144. So that means 144 is square of 12. Okay, na? Yeah. So let us see some patterns based on the square numbers. Okay, na? So I am just writing the square numbers from 1 to 9. Let us observe here. So 1 square value. So we have to write that 1 into 1 like 1 square. Okay, a number is multiplied by itself gives its square number. That means 5 into 5, 25. 25 is square of 5. Nothing but 5 square is 25. We should express like this. 5 square value is 25. Okay, now I am writing the square numbers from 1 to 9. So what is the 1 square value? 1 square is nothing but 1 into 1. 1 into 1 means 1 itself. So 2 square, 2 into 2, 2 into 2, 4. What is the 3 square value? 3 into 3, 9. Next, I am writing like this up to 9 squares. Okay, na? 5 square value is 25, 5 5s. 6 square value, 6 6 are 36. 7 square value, 7 7s 49. 8 square value 64 and 9 square value 81, 10 square value 100. Okay, na? Now check all these numbers 1 square to 10 square while observing all its unit place digits. All its units place digits. See the units place digit 1, 4, 9, 6, 5, 6, 9, 4, 1. Now see here 1 and 9. 1 square value and 9 square value end with the digit 1. So units place of 1 square and 9 square. Same way 1 square, 11 square, 21 square, 31 square all will end with the digit 1. Same way 9 square, 19 square, 29 square, 39 square all will ends with the digit 1. Okay, na? 1 and 9 ends with the digit 1. Next, 2 and 8. 2 and 8 are 2 square value and 8 square value ends with the digit 4. 3 and 7. 3 square value, 7 square value ends with the digit 9. 4 square value and 6 square value both are ends with the digit 6. 5 square is ends with the digit 5 itself. Okay, na? So simply while you are observing that here 1 plus 9, 10. While you are adding here 1 plus 9, 10. 2 plus 8, 10. 3 plus 7, 10. 4 plus 6, 10. 5 plus 5, 10. Okay, na? So while you are observing all its unit digits from 0 to 9. From 0 to 9. Observing that the units place digits are 2, 3, 7, 8 are missing. From 0 to 9, 2, 3, 7, 8 digits are missing, remaining all present here only. 0 is presented, 1 present, 2 not there here. In its units place, 2 is missing, 3 is also missing, 7 missing, 8 missing. So from 0 to 9, only these numbers are missing. So from this, we need to understand that if any number is ends with the digit 2, 3, 7, 8, they never becomes a square number. They never becomes a square number. Got it? While you are writing the square numbers from 1 to 10, we have identified some pattern here. That is, they never ends with the digits 2, 3, 7, 8. Okay. So from this we can say that a square number never ends with the digits 2, 3, 7, 8. Okay. So what is the square number? A number is multiplied by itself, gives it square number. Okay. A number is multiplied by itself 3 times, gives its cube number. Next. What is that? Cube number. So we'll think about the cube number later. So let us discuss the square and square roots first. A number is multiplied by itself, gives its square number. And from this we have decided that square number never ends with the digits 2, 3, 7, 8. Any square number never ends with the digit 2, 3, 7, 8. Okay now? Right. Next. Square root. Now we are going to discuss about the properties of a square root. Okay now? So properties of a square root. I told you that square root is nothing but inverse operation of a square number. Square root is nothing but inverse operation of a square number. So that means the first important property is root a into root b. Square root of a into square root of b is equals to square root of a into b. Okay? Square root of a into square root of b equals to root over a into b. Second one, square root of a by square root of b equals to root over a by b. That means while you are observing that multiplication and division symbols between two different square roots, we can take the square root of them. Okay na? But third one is square root of a plus square root of b is not equals to square root of a plus b. This is very, very important. Into and division can be accepted together, we can take a square root, but addition and subtraction also not accepted. Root over a minus root over b is not equals to root over a minus b, where a is greater than b, whatever. Okay now? So these are the mainly properties of a square number. That too we discussed that square number never ends with the digits 2, 3, 7, 8. Square number never ends with the digit 2, 3, 7, 8. Okay na? Now cube number, what is the cube number? Cube number means a number is multiplied by itself 3 times. A number is multiplied by itself 3 times is called its cube number. For example, 5 into 5 into 5. 5 into 5, that means 5 is presenting here 3 times. 5 into 5 into 5, itself it is multiplied 3 times. 5 5 is 25, 25 5 is 125. That means 125 is cube of 5. That means 5 cube value is 125. Same way, same like previous one we discussed that square root is inverse operation of square number. Same way cube root is inverse operation of cube number. That means cube root we should write like this. Cube root of 125 is 5. 5 cube value 125. Cube root of 125 value is 5. Okay. Now same way 6 cube value 6 into 6 into 6. 6 6 are 36. 36 6 are 216. So 6 cube value is 216 and the cube root of 216 is 6. Cube root of 216 is 6. Okay now. So this is about the cube number. So cube number also we are finding by using prime factor method and continued division, estimation method for cube root. But square root, continued division method we will use and prime factorization method. Okay now. Now while you are observing the cube number also, so 1 to 10 cubes I am going to write here. So any numbers are missing or not. Let us identify them first. So 1 cube value means 1 into 1 into 1, 1 itself. So 2 cube value is 8, 2 into 2 into 2, 2 2s are 4, 4 2s are 8. 3 cube value 27, 4 cube value 64, 5 cube value 125, 6 cube value 216, 7 cube 343, 8 cube 512 and 9 cube 729, 10 cube is 1000. Now just identify the all its unit place digits 0 to 9. 0 is there here. Next 1 is for 1 cube, 2 is for 8, 3 is for 7, 4 is for 4 itself, 5 itself, 6 itself, 7 8. So while you're observing is 2 cube is end with 8, 8 cube is end with 2. And 3 cube is end with 7, 7 cube is end with 3. So while you're observing the same digits which are not repeated or not ending in the place of square numbers 2, 3, 7, 8, the same numbers are interchanged here. 2 and 8 are interchanged. 2 cube end with 8, 8 cube is end with 2. 3 cube end with 7, 7 cube is end with 2, 7 cube end with 3. That means 0 to 9 all numbers are presenting in its units place digits, nothing else. Okay, na? 9 cube is end with 9 itself. Clear? So 0 to 9 all the numbers are presenting, so we cannot identify which is, that means the number cannot end with the so on digits and all, we cannot say that in cube numbers. But square numbers we can say that they never end with that is 2, 3, 7, 8. Yeah. So let us try exercise problems. So we'll go through it. A number is multiplied by itself 2 times, gives its square number. A number is multiplied by itself 3 times, gives its cube number. Okay, na? Yeah. Let us see some of the examples. That means practice problems are there. Yeah. Square of A. First question, practice sheet. First question. I am writing here. Yeah, square of A. Square of A is nothing but A square value is B, it seems. Square of A is B. That means A square equals to B. Then square root of B. Square root of B is how much? A. Example we have discussed already. 5 square value is 25 and square root of 25. Square root of 25 is 5. Am I right? So same way A square value is B, then square root of B value is A. So our answer is A. Okay. Yeah. Let us go to the question number 2. That is square root of 625. Square root of 625 is B. Then we need to find the value of square root of B. So first of all we need to find the square root of 625 by using the prime factor method or continued division method. Anything your wish. I am taking prime factorization method. 625. Last digit is 5, no? It will definitely come with 5 table. I am using 5 table here. 5 ones, 5 twos, 5 fives. 125 times. Again 5 table it will end. 5 twos, 10, 5 fives, 25. Again 5 table, 5 fives. Again 5 table, 5 ones. That means this 625 we can express as how many? 5 into 5 into 5 into 5. 4 times. 5 into 5 into 5 into 5. 5 into 5. From these 5s, these 2 times of 5, we can take 1 without the square root. Here also from these 2, we can take 1. 5 into 5 is 25. That means square root of 625 value is B. From this we can say that B value is 25. We got B value 25. Now again we need to find square root of B. Square root of B, B value is 25. B 25 we can write as 5 into 5. From these two 5s again only one 5 will come. Therefore square root of B equals to 5. Okay, no? Check once. First I found the value of square root of 625, I got the value of 25. Again 25 square root becomes 5. Answer root b value is 5. Okay, check. Next, question number 3. Third question, root over 0.9 into root over 1.6. So it is looking like one of the square root property. Root a into root b is nothing but root over a into b. That means root over 0.9 into 1.6. Okay, na? So I am converting the decimal numbers into fractional form. 0.9 we can write as 9 by 10 because point after only one digit 9 will be there. So denominator we remove the point and we can write the denominator 10 into 1.6 I can write as 16 by 10. Okay, na? Now multiply the numerators. 9 16s are 144. Or you can write this 9 as 3 into 3. We can write the 9 as 3 into 3 and 16 as 4 into 4. Denominator 10 into 10. So according to the square root of concept, from these two 3's, one 3 will come without root into from these two 4's, one 4 will come without root by from these two 10's, one 10 will come without root. Nothing but 3 into 4, 12. 12 by 10 convert into decimals, it is 1.2. So 12 by 10 value is 1.2. Okay, now? Yeah, that is the answer. Let us go to the question number 4. Okay. So the question number 4 is, among the following a cube number, cube of 4. Cube number of 4. That means cube of 4 nothing but 4 cube, right? 4 cube value how much? 4 into 4 into 4. 4 4s are 16. 16 4s are 64. Therefore 4 cube value is 64. So 64 is our required answer. Clear? Yeah. Please note it. So meanwhile I am going to arrange the first two questions. Right. So coming to question number 5. The question number 5 is given that the successor of square root of 169. Successor of square root of 169. 169 square root of 169 successor. So first of all we need to find the value of square root of 169. 169 is nothing but 13 into 13. 13 13s are 169 because 169 is a square number. 13 13s are 169. So in the square root from these two one number will come. That means square root of 169 is 13. Then what is the successor of 13? Successor of 13 is, successor means immediately next number. Successor of 13 is 14. Our required answer is 14. Okay, now? Yeah, coming to the question number 6. Among the following, which is not a perfect cube? Which is not a perfect cube? We have the rule for square number, perfect square or not we can say, because every that means perfect square is never ends with either 2, 3, 7, 8. If you identify any one of the number is ending with these digits, we can say that it is not a perfect square. But here perfect cube, asking about perfect cube, we need to check by doing the problem. Okay. So I am going through the options, that is 125. 125 is perfect cube or not. Second option is 1000 and third option is 3375 and the fourth option is 1234. Okay. So sir, how to find whether it is a cube number or not? I am taking the prime factors of these numbers. If they are having the same numbers 3 times, I can conclude that it is a cube number. Otherwise, I cannot take it as a cube number. So let us take the first option, 125. I am finding the prime factors here. 5 table, 5 2s 10, 5 5s 25. 5 25s are 125. Again 5 table, 5 5s 25. Again 5 table, 5 1s. That means 125 can be expressed as 5 into 5 into 5. 5 is presenting 3 times. That means 5 cube. 125 value 5 cube. So it is a cube number. Let us take 1000 here. Do prime factorization. 2 table I can take 2 5s are 10. That means 2 500s are 1000. 2 into 250 500. Again 2 table here 125. 125 again means 3 times will come. With 5, 5 25s, 5 5s, 5 1s. So 1000 we can express as 2 into 2 into 2 into 5 into 5 into 5. Okay, na? 2 is presenting 3 times, so I can write 2 cube. 5 is presenting 3 times, I can write 5 cube. 2 cube into 5 cube is nothing but 10 cube. That means 10 into 10 into 10, 10 tens, 100, 100 tens are 1000. So 1000 is a cube of 10. So it is also a cube number. Let us go to the third. What is the third one? 3375. Identify the prime factors. I am using 5 table here. 5 6 are 30, 5 7 is 35, 5 5 is 25. Okay, again 5 table. 5 1s are, 5 3s are 15. 5 times. Again 5 table. 5 2s, 5 7s. Now 3 table, 3 9s, 3 3s, 3 1s. Okay, na? 5, 3 times are there. 5 into 5 into 5, I can write 5 cube. Here 3 also 3 times are there, 3 cube. 5 into 3, 15 cube. So that means 3375. 3375 value is nothing but 15 cube. So first 3 options are cube numbers. So our required answer is fourth one, 1234. You can do prime factor like this. You won't get it is not a cube number. Okay, na? You will get that it is not a cube number. Clear? Yeah. Please check. Okay. So let us go to the next problem. Problem number 7. So it is given that the predecessor of a prime number, we have so many prime numbers. There are infinite number of prime numbers are there. From that, if you take any prime number, what is its predecessor? But we cannot say whether it exactly, because 2 is an even number. Let us write some prime numbers here. 2, 3, 5, 7, 11, 13. These are all prime numbers, right? Here asking about the predecessor, right? Yeah, predecessor of a prime number. Predecessor means immediately before one. So I am writing all its predecessors. What is the predecessor of 2? Predecessor of 2 is 1. Predecessor of 3 is 2. Predecessor of 5 is 4. Next 6, 10, 12. Now observe here. Up to 2 to 12 all are even numbers, but only 1 is an odd number, because these are all odd prime numbers. 2 only the even prime numbers. So that's why we are getting that only 1 time is odd number, remaining all even numbers. If there is no 2, we can say that the predecessor of a prime number is even always. But if there is a 2, that's why we can take the option either even or odd. It can be even number or it can be odd number also. So this is our required option. Okay, now check. Next, coming to the question number 8. The 8th question is square root of 0.0009. Square root of 0.0009. Now I am going to convert this decimal number in the form of fractions. So point after how many decimals? 1, 2, 3, 4. 4 decimals means while you are converting into fractional form, denominator is 10,000 will come. 4 decimals means 4 zeros will come. If you remove the decimal point, then the number will be 0 after 3 zeros. 1, 2, 3, 9. So 00009, it is nothing but 9 itself. So we can write that 9. Okay, na? 9 is a square number or not? Yes, it is a square number. 3 into 3, 9. Okay, and this 10,000 I can write 10 into 10, 100, 100 into 10, 1000, 1000 into 10, 10,000. Okay, now convert them into square root. From these two same numbers, one number will come without the root. So numerator only 1 3 will come. From denominator, these two tens, 110 we can write. Again from these two tens, 110 we can write. That means 3 by 10 into 10, 100. 3 by 100 converted into decimal form, 0.03. 3 by 100 convert into decimal form again, 0.03. That is our required answer. Okay, na? Next, question number 9. The ninth question is, the square of a prime number is, 2, 3, 5, 7, these are all prime numbers. If you take a square of this number, it will be 2 into 2, 3 into 3, 5 into 5, 7 into 7. That means these all will be composite numbers. More than 2 factors, a number containing more than 2 factors is called composite number. So while you are observing 7 having the prime factors as 1 and 7. Sorry, 7 square means 49 having the prime number. 7 square value how much? 49. 49 is having the prime number 1, 49 itself and 7 also. More than 2 factors, so it is a composite number. Okay, na? Yeah. So square of any prime number will be composite number. Let us find the cube root of 3375. Cube root of 3375. I think this problem we have already discussed through the option. Again, let us find through prime factorization method. 3375. I am taking 5 table here. 5 6 are 30, 5 7s, 5 5s. Again 5 table, 5 1s are, 5 3s are, 5 5s are. Again 5 table, 5 2s, 5 7s. Now 3 table here, 3 9s 27. 3 table, 3 3s are 9, 3 1s are 3. So here 3375 cube root of 5 is presenting 3 times, I can write 5 cube. 3 is presenting 3 times, I can write 5 cube. So cube root means from 3 numbers, 3 same numbers, only one number will be the answer without the root. Here also 3 cube means 3 into 3 into 3, only one number you should write. 5 into 3, 5 3s are 15. Therefore cube root of 3375 is 15. That means nothing but 15 into 15 into 15 value 3375. Okay, na? So practice sheet completed. Now let us go to the exercise problems. Okay. Now exercise 1. The first problem is 28 into root x. 28 into root x plus 1426 equals to 3 by 4 of 2872. So we need to find the value of x. So let us simplify this one. So I am writing this one 3 by 4 of is nothing but multiplication into 2872. Now 4 table we can cancel. 4 7s are 28 exactly. 4 1s are 4. 3 remains. 4 8s 32. So we will get the answer 3 into 718. LHS part as it is. 28 root x plus 1426. Now 28 root x equals to this plus 1426 transpose this side becomes 1426 with negative symbol minus 1426. Now multiply with 3 table, 3 8s 24, 2, 3 1s 3 plus 2 5, 3 7s 21. Now subtract both of them. 4 minus 6 not possible, 14 minus 6 is 8, now 4 minus 2 is 2, 1 minus 4 is not possible, 11 minus 4 is 7. 728 is the answer. Okay now? This is 28 into root x value. But we need to find x value now. So root x equal to 28 is multiplying here, transpose that side. Both will cancel in 7 tables, 7 4s 28. Here 7 10s are 70, 7 4s 28. Again 4 table cancel here. 4 2s are 8. So 24 means 4 6 are 24. So root x value is 26. Root x value is 26. To removing a square root, we do squaring on both sides. What do we do? Squaring on both sides. Now here square root cancel, x only remains. 26 square is nothing but 26 into 26, 676. 26 into 26 will be 676. Therefore the answer is 676. We found the value. Okay now? First we simplified, then this plus value transpose as a negative, did subtraction, 28 is multiplied, transpose divide, cancellation do, we will get the answer 26. Root x value is 26, but we need to find x value, that's why I am doing square root on both sides, squaring on both sides. Here square root cancel, 26 square value 676, that's it. Okay, let us go to the second problem. That is cube root of 2744. Cube root means we should write like this, cube root symbol. This is the symbol for cube root. This is the symbol for square root. This is the symbol for fourth root. We should read this one as fourth root, fifth root, sixth root, fourth root. This is fifth root, sixth root. Okay na? So cube root means you should write like this. Okay. So 2744. How to find the square root? We learn the prime factorization method. I am taking 2 table here. 2 1s are 2, 2 3s are 6, 2 7s, 2 2s. 1372 times. Again 2 table 6 times 2, 2 8 times 2, 2 6 are. Again 2 table 2 3s, 2 4s, 2 3s. Now 2 table won't come, 3 table also won't come, 7 table will come. 7 4s 28, 63 means 7 9s are 63. 343 is nothing but 7 cube value. I told you already, 7 7s 49, 7 1s. That means cube root of 2744 can be expressed as 2 into 2 into 2. 2 is presenting 3 times, so 7 also presenting 3 times. That means we can write 2 cube into 7 cube, nothing but 2 into 7 whole cube. Cube root cancel, 2 into 7 value is 14. Therefore, cube root of 2744 is cube root of this number will be 14. That means 14 cube value 2744. Note. Let us go to the problem number 3. What is the third problem here? Third problem. Third one completed now. Second one completed. Third one. The cube root of 0.000216. First convert the decimal numbers into fractional form. So denominator, how many decimals are there? How many digits are there? 1, 2, 3, 4, 5, 6. 6 digits means we need to keep 6 zeros in denominator. And remove the decimal point, write the number 4 zeros after 216. So 4 zeros is never taken as a value here. After the number we will keep the zeros, means there is a value for that. If you keep the zeros before the number, there is no value for that. So it is only 216. So 216, how to find the square root? By doing the prime factorization method. But I know 216 is 6 cube. 6 into 6 into 6, 6 6 are 36. 36 6 are 216. Now, these are also, I am separating like this. How many zeros are there here? 6 zeros. So, 1, 2, 3. 2 zeros I can take it as 100 into 100 into 100. That means 6 by 100, 6 by 100, 6 by 100. So, 6 by 100 3 times. So, I can write 6 by 100 whole cube. So, cube root cancel. So, we will have only 6 by 100. That means 0.06. 6 by 100 means 0.06. Okay, now? Or from these 3 sixes, 1 6 will come. From these 3 hundreds, 100 will come. 6 by 100 value 0.06. Note it. Next, question number 4. What is the question number 4? The least number by which 3087 may be multiplied to get a perfect cube. What is the least number to change this number into a perfect cube? That means this is not a perfect cube. To make this number as a perfect cube, we need to multiply a number. What is the smallest number? Let us find through the prime factorization. So last digit is odd number, so we cannot take the 2 table. So let us try 3 table will come. Yes, 3 table is coming. We know the divisibility rule. Sum of all digits of a number is multiple of 3. Then we can say that the number entirely divisible by or divisible by 3 table. Okay, na? Check that. Yeah, 1 second, children. Yeah, so let us take the prime factor, prime number 3. 3 tens are 30, 3 twos are 6, here 2 remains 27, 3 nines 27. Again 3 table, 3 threes 9, here 1 remainder 12, 3 fours are 12, 3 threes are 9. So 343, we know that 343 value 7 cube. So 7 table, 7 49s are 343. 7 sevens are 49, 7 ones are 7. That means 3087 can be expressed as 3 into 3 into 7 into 7 into 7. Here 7 is present in 3 times, so 7 cube we can write. But 3 is presenting only 2 times, that's why it is not a perfect cube. If 3 is also being 1 more time, then it is a perfect cube. That means here 1 3 is missing. Therefore, the smallest number to multiply. Therefore, the smallest number to multiply. What is the missing here to become a cube number? 3. Okay, na? If you multiply with 3, then here also 3 into 3 into 3 becomes 3 cube. 3 cube into 7 cube, 3 7 is 21 cube. We will get the answer. Okay, na? Next question. Let us go to the question number 5. Yeah, question number 5 is, by what least number 4320 multiplied to obtain a number which is a perfect cube? Again, same answer. What is the perfect cube? We have to multiply. least number to be multiplied. Let us find it. So I can take 2 table here directly. 2 2s are 4, 2 1s are 2, 2 6. So 2160. Again 2 table. 2 1s are 2, 0, 8 times 1080. Again 2 table. 2 5s 10, 2 540. 2 table 270. Again now I can take 3 table directly. 3 9s are 27. 3 30s. 3 10s. Again 2 table 5 times, 5 table 1 time. Now while you are observing here, 4320 can be expressed as, here 2 is how many times here? 3 times 2 cube. Here 2 is here 2 times only. 2 square I can write like this, because cube number means I have first 3 2's I can take in as a cube number, 2 cube. And here 1 2, here 1 2 remains. Okay, leave it. So remaining 3 how many times? 3 also 3 times I can write 3 cube. Okay na? Now what is remaining? 5. 5 is presenting only 1 time. So first one, this is also a cube. This is a cube number 2 cube. 3 cube, it is a cube number. Here 1 is missing what? 1 2 is missing here. Here only 1 5 is there. We need 5 into 5 into 5. 5 cube. 3 5s are there, no? So 2 5s are missing. Okay. So 5 into 5, 25. 25 into 2, 50. Therefore the smallest number is 50. Okay now? Therefore the smallest number is 50. So let us go to the next question. Question number 6. Yeah. Find the square root of 272 square minus 128 square. Now we are applying one of the algebraic identity, that is a square minus b square. First one a square, second one b square. A square minus b square formula a plus b into a minus b. Same way, let us find out this value. 272 square minus 128 square is equals to, I can write 272 plus 128, a plus b. Next a minus b. 272 minus 128. Okay na? So 272 plus 128 is 400. This one into 272 minus 128 value is 144. Okay na? Now this one I am writing here, that is 400 into 144. Find 144 value. I know that is 144 value is 12 12s are 144. 12 12s are 144. And also I know that 4 is a square number. 4 value, 2 2s are 4. 2 2s are 4. That means here 2 zeros are there, no? 20 into 20. From these 20s, 2 20s, 120 will come outside. Here 112 will come outside. 2 12s are 24. So the required answer is 240. Okay na? 20 12s are 240. So I am using one of the famous algebraic identity, a plus b whole square equal to a square minus b square. Sorry, a plus b into a minus b equals to a square minus b square. Okay na? Check. Let us go to the next problem. Problem number 7. Okay na? The 7th question is cube root 2 if cube root 2 into cube root 4 equals to x. This is the condition is given. Cube root 2 into cube root 4 equals to x. Then find the value of x. X value we need to find. In square and square root, I told you the condition that root a into root b is nothing but root or a into b. Same like that, these two are also cube roots. So we can write cube root of 2 into 4, that is equals to x. So simply I can write cube root of 2 into 4, I can write as 2 into 2. 4 I can write as 2 into 2. We learned already, if any number in cube root 3 times, same number 3 times, only one number will come without root. So answer is 2. X value is 2. Okay, na? Question number 8. Question number 8. So let us see the question number 8. Find the value of root over 1.1664. Square root, it is not a cube root. So square root of, I am changing this one into decimal form. How many decimals are there? 4 decimals. So denominator 4 zeros. 4 zeros means 10,000. 100 into 100. Now without the decimal, remove the decimal. What are the numbers? 11664. Without the decimal, it is 11664. Okay, na? Now the denominator I can write this one as 100 into 100. From these two hundreds, 100 will come without the root. Now I have to write this one, 11664. Let us find the prime factors here. I am taking the 2 table. 2 5s are 10. 2 8s are 16. 2 3s are 6. 2 2s. Again 2 table here. 2 2s are, 2 9s are, 2 1s are, 2 6s are. Again 2 table. 2 1s, 2 4s are 8. 2 5s are 10 and 8 times. So let us take possibility times. 7s here, 2 times here, 2 9s. Yeah, 2 table won't come. Now I am going to take 3 table. 3 2s are 6. 3 4s 12. 3 3s. Again 2 table. 3 table. 3 8s are 24. 3 1s. Again 3 table 27 times. 3 table 9 times. 3 table 3 times. 3 table 1 time. Now see here. 2 how many times here? 4 times. So I can write 2 square into 2 square. Am I right? 2 square into 2 square. Because it is square root now. That's why I am writing in the powers of 2. If it is square root, I can write 2 cube, 2 cube like that. Okay, 3 how many times? 1, 2, 3. 3 times 3 square. 3 square into 3 square into 3 square. Now squares, 2 numbers are presenting means 1 will come. From this 2, 1, 2 will come. 2 square means only 1, 2 will come. Here 2, 3 into 3 into 3 by 100. Only 100 will come. 100 into 100 is nothing but 100 square. Now multiply 2 into 2, 4. 4 into 27. 4 27s are 108. Yes, 108 by 100. Nothing but 1.08. The answer is 1.08. Check. So next question. Question number 9. That is, if square root of 243 by square root of 363. This value is x, it seems. We need to find the value of x. So by the property of a square root, root over a by root over b is nothing but root over a by b. Single root I can write 243 by 363. That is equal to x. Both, while you are observing 243, 363, both will come in. Cancelled in 3 table here. Here 3 table, 3 8s 24, 3 1s are 3, 81 here. Here 3 table, 3 1s are, 3 2s are, 3 1s are. Yes, we will get that answer. 81 is nothing but a square number. I think you should learn some of the square numbers, at least 20 squares. Or 30 square numbers, 20 cubes you should learn. Now 81 is nothing but 9 9s are 81. 9 9s are 81. Now 121 is nothing but 11 11s are 121. So if it is a square root, we can write from these two 9s, one 9 will come. From these two 11s, one 11 will come. What is x value here? 9 by 11. X value is 9 by 11. Okay, no? So 9 by 11, but the answer is given in the decimals. So let us check. Always the denominator as divisor, numerator as dividend. So 11 zeros are 0, 9 again, put point, take 0. 11 eights are 88, 2 remainder, 0. 11 ones are 11, 9. Okay, na? So 9 again, 0. 11 eights are again 88. That means 81, 81, 81 like that will come. So we can write this one as 0.81 bar. This is our required answer. 0.81 bar. That is the 9th problem. So let us go to the question number 10. Find the value of root 45, square root of 45, but we know that 45 is not a square number. That's why we are asking that value up to 3 decimals and take root 5 as 2.23607. We should take root 5 as 2.23607 it seems. So very easily we can take by using the prime factors method here. 45 I can write as 9 5s are 45. Can I write like this? Yes, 9 5s are 45. 9 is nothing but 3 into 3. 3 3s are 9. 3 into 3 into 5. From these 2 3s, 1 3 will come without the root. And what is remaining? Root 5. 5 only one time is present. Root is applicable for that. So 3 into root 5. 3 into root 5 value is already given, that is 2.23607. Multiply with 3 table, 3 7s 21, 3 6 are 18, 9 1 7 plus 7.6. 6.70821 is our required answer. Do multiply, you will get the answer like this. Question number 11. Now see the question number 11. If 5x is a perfect cube, 5x is a perfect cube it seems, then the least number of 5s that must be contained in the prime factorization of x. What is the least number of 5? Here 5 into x we can write, 5x we can write 5 into x. What is the least number of times 5 must be present to become a cube number? Cube number means 5 into 5 into 5. So in the place of x I can write 2 times 5 into 5. So how many times are there? 2 times. Answer is 2. 2 times we need x. 2 times we need 5 to become the value is perfect cube, because it is already 5 is there. For example, the question is given 9x is a perfect cube. If 9x is a perfect cube, what is the value of 9? Value of 9. How many times you have to take the value of 9? It is also taken like this. 9 into x, so that means 9 into 9 into 9 like this. 2 times. Okay, na? Next, question number 12. Question number 12. Yeah, let us see the question. Yeah, if 3 root 5 plus root over 125 value is 17.88 it seems, then the value of, we need to find the value of root 80 plus 6 root 5. Okay, na? So let us identify this value. So I am taking the given condition, this one. Okay. So 3 root 5 as it is I am writing, plus root over 125. 125 I am doing the prime factors here. 125 5 table, 5 25s are 125, 5 5s are 25, 5 1s are 125 is nothing but a cube number, 5 into 5 into 5. That means I am writing this 125 as 5 into 5 into 5. This value is given 17.88. Okay, now this 3 root 5 as it is. From these two 5s, I can write 5, 1 5 without the root, 5. What is remaining? 1 more root 5. Now here root 5, both are same. Root 5 here 3 times, here 5 times, total 8 times. This is 8 root 5 value. 8 root 5 value is 17.88 it seems. 8 root 5 value is 17.88. Now we need to find the value of root 80 plus 6 root 5. Again find the prime factors for 80 here. I am taking 5 table here. 5 table, 5 ones are 5, 5 6 are 16 times. Okay, na? So this one I can write as 4 into 4, yes, because of square number. So root 80 I can write 5 into 4 into 4 plus 6 root 5. Okay, that is equals to 2 times 4 is presenting, so 4 will come without the root. 4 root 5. This is 6 root 5. Total 10 root 5. Am I right? 10 into root 5. If you know the root 5 value, 2.236607, we can just multiply with that answer. So that means 10 into root 5 value we know from the previous problem, 2.23607. If any decimal number is multiplied by 10, the decimal point move right side one place. 100 means move right side 2 places. Here 10 is there, no, so it will be move one side right place. So this point will come here. 22.3607 is our required answer. Okay, na? Check. Next question. Question number 13. Yeah, see this question, children. So this is what should be added to 1752? 1752 to make a perfect square. Now, starting we discussed about that prime number. To find the square root of a number, we are using prime factor method and continuous division method, I said. Here we should use only continuous division method. Okay, na? Because the question is asking that what is the smallest number to add, what is the smallest number to add, what is the smallest number to subtract. We should use the continuous division method. But the question is asked what is the smallest number to multiply, what is the smallest number to divide. We will use the prime factor method. Now check how to do the continuous division method. Check right here. There are some rules. First rule, the given number we have to separate as pairwise, two digits. 2 digit means 2, a pair, right? So from its right side. So right side means 2 onwards, 2 and 5, 1 pair. 7 and 1, second pair, 2 pairs. Because 4 digit number, I can separate 2 digits. That is first step. Second step, we should take the square number nearer the values. Now what is here? 17. Nearer square numbers, I am counting the square number. 3 3 is 9, 4 4 16, 5 5 is 25. 25 is more than 17. I can take 4s. 4 4s are 16. Okay, na? What is the first step I took? I just separated pairs. And next I am using the square numbers. Only square numbers we should use here. 4 4s, 3 3, 6 6 are 7 7 are like that. Okay, subtract. 17 minus 16 is 1. Bring 52 down. Pair only we should bring 152. Okay, na? Now the same for added here. 4 plus 4 becomes 8. Okay, na? Right. Now we already got 8, but here we don't know, that's why we are taking 4 4s. So same way here also we should take 1 1s or 2 2s, like that we should take. Okay na? Yeah. If you take 2 times, 82 2s are 164. 164 is more than 52. Yes, more than 52. So it is not possible for us. So I am taking 81 ones are 81 ones are 81 only. Okay now? Here and here same number we should take. If you take here 2, here also you have to take 2. Okay, 2 minus 1 is 1. 15 minus 8 is 71. That means 1752. If you add 71 to this number, it will be the square number. Therefore, what is the smallest number here? 71. The smallest number to add is 71. Okay now? Check. Yeah, sorry. Yes, not add here. Because 71 we got remainder, no. We should remove means we will get. So add up means, so just here add this 71. 71 we got the remainder, no. Okay na? Now add this remainder to this number. That means I will take here 2 times. Okay na? 82 2s. What is the answer here? 82 2s are 164. What is that? 164. When you get that subtraction, it is not possible. 152 minus 164 is not possible. Take reversely. 164 minus 152 is 12. Minus 12. Bigger number is negative, no? So minus 12. That means we got less. 12 or less. If you add this 12 to the given number, we will get exactly the square number. 42 square will come. So the smallest number to add is 12. If you add 12, then exactly we will get the answer. Because add here ask, if you subtract the previous one, 71 will be the answer. Okay? Check that. Now question number 14. Yeah, question number 14. The question is, what is the smallest number to subtract from 1300 to make it a perfect square number? Same like this only, 1300 I am taking, than this one also. Now this time question is asking about the subtraction. First one is addition, no? So first step, separating as pairs. 3 3s here. 4 4 the 16. 16 is more than 13. So I can take 3 3s. 3 3s are 9. So remainder 4. 2 zeros down. Now 3 plus 3. This 3 I have to add it here. 3 plus 3 6. Now I have to take the number here. 61 1s 61. If you take 2, 62 2s, 63 3s, 64 4s, 65. 66 6 I will take. 66 6 are 6 6 are 36. 3 6 6 are 36 plus 3 39. So what is the number? Remainder 4. This 4 is remaining. Remainder will be getting the 4. That we have to subtract. So smallest number to subtract is 4. Okay na? Check. Question number 15. Find the least number which when multiplied by 882 gives a perfect square number. Same way. Multiply means we need to use a prime factor method. That problem you have to try that. Okay na? So remaining problems will be there. We will discuss in next class. Thank you one and all. Have a nice day. Bye bye.